tutorial series of the wireless communication. I am your instructor Varsha Tank. Let's start our today's lecture series. So at the end of this video, all of you will be able to learn about the coherence bandwidth. Then we will learn about what is the coherence time, and then we will see what is diversity and which are the different types of diversity techniques. So let's learn with the coherence bandwidth. So first of all, what is it? So statistical measurement of the different frequency over the radio channel that is flat, so that is known as the coherence bandwidth. Okay, so strong potential for the amplitude correlation is required. Now let's see if the frequency correlation is above the 90%, that is 0.9, then coherence bandwidth can be found out using the formula. Bandwidth is equal to 1 upon 50 into RMS delay spread. Okay, and if the frequency correlation is above the 50%, then the coherence bandwidth that is defined using the formula 1 upon 5 into RMS delay spread. Now let's see the example related to this coherence bandwidth. So determine the coherence bandwidth that is 90% and coherence bandwidth 50% for an RMS delay spread that is of the 8.47 nanosecond. Okay, RMS, that is root mean square. Okay, so for the RMS delay spread, we have to define the bandwidth for the 90% and for the 50%. So all of you know the formula for this. So let's put the formula in this. So first of all, for the coherence bandwidth of the 90%, the formula is equal to 1 upon 50 into RMS delay spread, as we have seen in the previous slide. Okay, so here just put the value of the RMS delay spread that is given to you, that is 8.47 nanoseconds. Now you should have to convert in these seconds. So to convert it in seconds, you require to multiply by 10 raised to minus 9. So here substitute it. So 50 into 8.47 into 10 raised to minus 9. Now if you will do this, if you will substitute this, you will get the answer 2.3612 megahertz. That is the coherence bandwidth at the 90%. Now the coherence bandwidth at the 50%. So for the 50%, we know the formula, that is 1 upon 5 into RMS delay spread. So 1 divided by 5 into 8.47 nanoseconds. Again you have to convert this nanosecond into seconds. So you should require it multiplied by 10 raised to minus 9. Okay, so whenever you substitute it, so 10 raised to minus will come the upper side, so it will become the 10 raised to 9 divided by 5 into 8.47, and if you will calculate this, you will get the answer 23.612 megahertz. So like this way we can define the coherence bandwidth. Now let's learn about what is the coherence time. Okay, so coherence time, that is denoted as a TC, is the time domain dual of the Doppler spread. Okay, so the vehicle is moving based on, depends on that the Doppler spreads is occurred. So the coherence time, that is the time domain dual of the Doppler spread. So it is used to characterize the time varying nature of the frequency depersiveness of the channel in the time domain. Okay, so a slowly changing channel has a large coherence time. So coherence time, that is given by the formula TC is equal to 9 upon 16 pi, that is FRM. Now let's learn about what is diversity. Okay, so diversity, that means what? The superpositions of the multiple signal at the receiver cause the random amplitude variation, which is known as the fading. Okay, fading, in short we can say unwanted signal. Okay, we can say also the disturbance in the signal, that is known as the fading. Okay, we have already learned what is small scale fading and which are the different types of this small scale fading based on the Doppler spread and delay spread. So superposition of the multiple signal at the receiver cause the random amplitude variation. The amplitude variation is that is known as the fading. A diversity mechanism is used to decrease the effect of the fading, that is called the diversity. Okay, so in diversity mechanism, multiple copies of the same data is transmitted to the receiver through the multiple path of the channel, and the decision is made by the receiver without knowing to the transmitter. Okay, so what will happen in the diversity? We are sending the same data multiple times, okay, on the multiple signals to the receiver, and the decisions will be made by the receiver which signals will be received by it or which not received by it. Okay, so that is the diversity techniques. Now let's see which are the different diversity techniques are there. So here you can see these are the different types of diversity technique it is given. Space diversity is there, time diversity is there, frequency diversity, and the polarization diversity is there. So let's learn about this technique in detail. So first of all, let's learn about the space diversity. So what is space diversity? Replica of the same signal is transmitted through the different antenna. Okay, you are sending the same signal through the different antenna to the receiver, so that is known as the space diversity. So space should be between adjacent antennas so that channel gain will be independent of the signal path. So here space is required between two adjacent antenna, so that should have the channel gain that is independent of the signal path. Okay, that signal is not interfere. Space diversity may give a path that avoids shadowing and also decrease the large scale fading. Okay, where it is used to decrease the large scale fading, and space diversity it gives the path that avoids the shadowing also. Space diversity offers the different path without an increase in the transmitter power or the bandwidth. Now here you can see this is the example related, this figure shows the space diversity. Here no diversity is there because single input and single output is there. Here receiver diversity is there, that single input and multiple output is there. And here you can see the transmitter diversity is there. Why? Because different transmitter is used to transmit the signal. And here you can see the multi-input and multi-output is there because multiple transmitters are there and multiple receivers are there. So now this is the generalized figure for the space diversity. Okay, so here you can see meaning of the space diversity is what? We are using the different signal for the transmitting the same signal. Okay, so here you can see the different antenna is used, that is 1 to m, and the gain is independent. Okay, so gain 1, gain 2 up to gain m is that is the variable gain. Now switching logic or demodulator will be used at the receiver side, which signal should have to be received. That's why. So this figure shows the space diversity. Now space diversity reception methods can be classified into 4 categories. Which are the 4 categories? That is selection diversity, feedback or scanning diversity, maximal ratio combining, and equal gain diversity. So these are the 4 types of different diversities are there, that is in the space diversity. Now let's learn about the selection diversity. So in selective diversity, combining the branches having the strongest received signal will be selected. Okay, so in selective diversity we will select the strongest signal. Okay, so in selective diversity method n numbers of demodulators are used and their gains can be adjusted to give the mean signal to noise ratio, that is SNR, for every diversity branch. So the antenna signal will be sampled. So finally the bad signal that poses a good signal strength will be sent to the demodulator. So here it is known as the selection diversity because we are selecting the strongest signal. Now next one is the feedback or scanning diversity. So scanning diversity is very similar to the selection diversity, except that instead of always using the best M signal, the M signals are scanned in the fixed sequence until one is found to be above the predetermined threshold value, that is say alpha. So here what we are doing, we have set one threshold value, that is alpha. We are accepting all the signals and only that signals will go to the demodulator which have the determined value of the threshold, that is alpha. So the signal is then received until it falls below the threshold and the scanning process is again initiated. So demerit of this method is what? the fading level reduction is less than the other diversity techniques. Now, the advantage with this method is that it is very simple to implement. Only one receiver is required. Why? Because we just have to accept the signal that is above the predetermined threshold. A block diagram that is shown over here, you can see the different antennas they are sending the signals. Okay, and here the comparator is that comparator will compare using the threshold value, predetermined threshold. If the predetermined threshold value is that, then it will be given to the demodulator and the signals will be received by the receiver. And here short-term average will be used to use in the comparator to compare the signal that at the proper threshold value. Now next is the maximal ratio combining technique. Okay, so the concept of this method is that all the n branch signals are combined coherently with necessary weighting coefficient for every diversity branch signal to that reductions for fading will be better, leading to the overall improvement of the system performance. So maximal ratio combining technique, its name suggests we are combining each and every signals. Okay, so unlike selection diversity, the signals are co-phased before the addition process, and for this individual receiver and phasing circuits are must for all the antennas element. So we will require the individual circuit phasing. Now here in the output, signal of the maximal ratio combiner will be such that the sum of the individual signal to the noise ratio values will be equal to the SNR of the output signal is the measure. So here you can see in the figure, that is the mechanism is given to you, that maximal ratio combining, you are using the different antenna, you are sending the signals at the different gain, and it will be received by the co-phase, and the that whatever the signals that we will receive, that will be co-phased, and we are finding the sum of unit of that particular signals, and then the detector unit will be used and it will detect it is up to SNR ratio or not, and then the output will be given. That means then the signals is received. Now what are the advantages of the maximal ratio combiner technique? So maximal ratio combiner generates an acceptable SNR value. Okay, accuracy is very much high compared to the other diversity technique and produce the best reduction of the fading. Okay, so compared to the previous technique, here we have the best reduction of the fading. Now next is the equal gain diversity. So in certain cases, it is not convenient to provide for the variable weighting capability required for the true maximal ratio combining. So in last slide, we have seen the different antennas is used at the different gaining. Okay, so in such cases, the branch weights are all set to unity, but the signals from each branch are co-phased. So to provide the equal gain combining diversity. So this signals they are transmitting with the equal gain of the antenna. This allows the receiver to exploit the signals that are the simultaneously received on each branch. Okay, so received by the receiver at the each branch. Now the possibility of the producing an acceptable signal from the numbers of the unacceptable input is still needed, and the performance is only marginally inferior to the maximal ratio combining and the superior to the selection diversity. Now next technique is what? The time diversity techniques. Okay, so in the time diversity methods, the information is transmitted repeatedly at the specific time. Okay, so after suppose the time is decided, if the response will not come back, again the transmitter will transmit the signals at the particular time. Okay, so time diversity is that. So repeatedly at the specific time by spacing spacing that would exceed the coherence time of the mobile channel, and this will lead to the repetitions of the signal for the several times irrespective of the fading conditions. Okay, so thus when the identical information is sent for the different time slots, it is possible to obtain the diversity branch signals because we are sending the signal at the particular time. Okay, so the time diversity technique is well suited for the spread spectrum, that is the CDMA system, and which the rake receiver is used for the reception. Now what is the rake receiver? That we will see in the upcoming lectures. Now next diversity technique is the frequency diversity technique. So in this method of the frequency diversity, the information is transmitted on many carrier frequency. Time diversity, that means we are sending at a different time. Frequency diversity, that means we are sending at the different frequency. Okay, so the idea behind this is that frequencies are separated by more than that of the coherence bandwidth of the mobile channel. This would be uncorrelated with each other, and hence this would not experience the same fading status. Uncorrelated frequencies are there. Okay, so if the frequency will not match, then the fading will not match also, because different fadings are there at the different frequency. Okay, so the frequency diversity scheme is applied in the microwave field whenever the line of sight link is used. Okay, so that is in the line of sight link, they may carry many channel frequency division multiplex mode. So that is we used in the FDM in the LOS. So here you can see this, we are sending the signals at the different frequency. Okay, and the receiver will receive it. Now, there are chances of the deep fades in the frequency diversity. Why? Because the tropospheric propagation and the resulting refractions of the signal. Okay, we are sending at the different frequency, so tropospheric propagations is also different for each and every signals, because we are sending at the different frequency. The fading variation independence factor between the separated frequency component is the main effect with respect to the land mobile communication, and this is known as the frequency diversity effect, because same reason we are using the different frequency, so we have the different diversity effect for the frequency. So thus the frequency diversity is popular diversity reception techniques among all the techniques. Now next one is the polarization diversity. Okay, so the polarization diversity require two transmitter and the two receiving antenna with different polarization. Okay, we have already learned what is the vertical polarization and the horizontal polarization in the previous lecture. Okay, so the transmission wave with two different polarization constitute two different paths. Okay, transmission wave with two different polarization. For example, if we are considering the vertical polarization or we are considering the horizontal polarization, then we have the different path for that. So this provide only two different diversity branches. Polarization diversity uses half power by dividing the power between two different polarized antenna. So in this video, we have learned about what is the coherence bandwidth and the example related to this, what is the coherence time and what is the diversity and which are the different types of diversity, like the space diversity, in which also we have the different types of it, frequency diversity, polarization diversity, etc. So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.